Kubernetes or K3s. The names look very similar, but the right choice directly affects your server costs, deployment time, and operational workload. In this video, we will compare both systems across architecture, resource usage, high availability, security, and real-world use cases. First, let's clarify the core concept. Kubernetes is an orchestration platform that deploys, scales, and manages containerized applications. A cluster contains a control plane and worker nodes. The API server is the entry point for every request. The scheduler chooses which node should run a new pod. The controller manager continuously moves the current state toward the desired state. etcd stores the cluster's state. On worker nodes, the kubelet, networking components, and container runtime keep workloads running. This architecture is powerful, but installation, networking, storage, ingress, certificates, and upgrades may need to be planned and managed separately. K3s is not a completely different product from Kubernetes. It is a lightweight, conformant Kubernetes distribution. It uses the same concepts: pods, deployments, services, ingress, config maps, and secrets. It works with kubectl and Helm. This means most application manifests you learn on K3s can move to standard Kubernetes environments. The real difference is packaging and operational approach. K3s bundles control plane components into a single binary and process. It includes frequently used components such as containered, flannel, core DNS, Trafic, service LB, and the local path provisioner. As a result, creating your first cluster is much faster. The installation difference is immediately visible. When you build standard Kubernetes with kubeadm, you plan the container, runtime, network, plugin, kubelet configuration, control plane, certificates, and sometimes a load balancer. That flexibility is valuable in enterprise environments because every component can match your requirements. With K3s, a working server can be created with a single command, sensible defaults are included, and much of certificate management is automated. But simple installation does not eliminate planning. Firewall rules, backups, persistent storage, DNS, permissions, and your upgrade strategy are still your responsibility. K3s stands out in resource efficiency, reducing unnecessary or cloud-specific components, packaging the control plane more compactly, and supporting SQLite as a default option creates a lower starting footprint on small machines. That makes K3s attractive for Raspberry Pi devices, edge computing, development environments, home labs, and low-cost virtual private servers. But remember an important point. The platform name alone does not determine real resource usage. Your pod count, logging stack, Elasticsearch, databases, ingress traffic, monitoring, and installed add-ons can consume far more CPU and memory than the control plane itself. Now consider the data layer. In a single server K3s installation, the default data store can be SQLite. It is simple and practical, but it cannot be used for a multi-server cluster. A highly available K3s installation can use embedded etcd or a supported external data store, such as PostgreSQL, MySQL, or etcd. High availability with embedded etcd requires at least 3 server nodes and follows quorum rules. The server count is normally odd. 3 servers tolerate the loss of 1 server, 5 servers tolerate the loss of 2. Disk latency is critical here. Slow storage can damage etcd performance and overall cluster stability. Can K3s run in production? Yes. K3s is not limited to tutorials or toy projects. It can run production workloads for small and medium services, edge systems, branch locations, Internet of Things environments, and resource-constrained servers. But when the control plane and applications share one K3s server, that machine becomes a single point of failure. If it stops, both the cluster and the applications become unavailable. For critical systems, consider at least 3 server nodes, a stable registration or load balancer address, regular data store snapshots, and tested restoration procedures. High availability is not achieved by simply setting the application replica count to 3. Standard Kubernetes is strongest when you need maximum flexibility and the broadest ecosystem. Large organizations may require different CNI solutions, advanced CSI storage drivers, cloud controller integration, custom admission policies, multi-zone topology, or clusters that scale to thousands of nodes. You can build your own cluster with KubeADEM or choose a managed service such as EKS, AKS, or GKE. Managed Kubernetes delegates much of control plane operation to the cloud provider. So, the practical comparison is sometimes not K3s versus self-managed Kubernetes, but K3s versus managed Kubernetes. Convenience, cost, and level of control should be evaluated together. A common misconception is that K3s must be missing most Kubernetes features because it is lightweight. That is incorrect. K3s is a conformant Kubernetes distribution and uses the standard Kubernetes APIs. Deployments, stateful sets, daemon sets, jobs, cron jobs, the horizontal pod autoscaler, namespaces, role-based access control, and network policies can all be used. Default components can still differ. K3s includes Flannel and Traefik, for example. If your organization standardizes on Cilium, NGINX Ingress, or another storage solution, you may need to disable the defaults and install your preferred components. Portability is high, but always review add-on dependencies. The same security fundamentals apply to both systems. Do not expose the API server to the public internet without a clear need. Grant role-based access control permissions according to the principle of least privilege. Never store secret values as plain text in a Git repository. Use network policies. Scan container images, prefer fixed version tags, and regularly update both the control plane and worker nodes. K3s provides secure defaults and automated certificate management, but that does not make a cluster automatically secure. Also, the built-in service load balancer is not the same thing as a true external load balancer in front of highly available server nodes. Let's simplify the decision. If you run your own applications on one or several virtual private servers and want low cost, quick setup, and easier maintenance, K3s is often the right starting point. It is also a strong choice for edge, Internet of Things, lab, and developer clusters. If you need very large-scale, deep enterprise integrations, specialized networking and storage, or a provider-supported platform, standard or managed Kubernetes may be more appropriate. When the team is small, do not increase complexity just because a technology is popular. Choose the simplest solution that delivers API compatibility, fault tolerance, backups, security, and observability. In summary, K3s is not a competitor to Kubernetes. It is a lightweight distribution that packages Kubernetes more simply and aims to reduce operational overhead. Being small does not mean being unsuitable for production, but a single node does not provide high availability. The right choice depends on scale, team experience, budget, add-on requirements, and acceptable downtime. On my own low-cost servers, I prefer K3s when I want fast deployments and straightforward management. Which one are you using? Share your experience in the comments and subscribe to the channel for more real-world DevOps content.